Hello, everyone. I'm Milind Bhandarkar. I'm the Chief Architect at HPE Ezmeral Group, and I'll be talking about our Presto DB inside HPE Ezmeral Unified Analytics platform. So a little bit about me. I've been in this whole big data space before it was called big data, starting as one of the first engineers to start working on what later became known as the Hadoop project within Yahoo. Have been contributing or have been contributing to Apache Hadoop since very early versions, even 0.1 version. After Yahoo went on to lead Hadoop strategy at Greenplum, which was a division of EMC at that point, and later became Pivotal. So helped launch the Pivotal HD distribution that included our core contributions, data warehousing platform called Hawk, running directly on top of Hadoop, as well as in-memory platform called Gemfire XD. Right. Uh, After 2015, I sort of shifted my gears and rather than focusing on scale only, started shifting towards speed at scale. So, founded a company called Ampool, where we built a distributed in-memory caching layer that was suitable for analytics. And Earlier, we basically had that distributed in-memory caching layer for various different analytical frameworks such as Spark, even MapReduce, Hive, etc. But finally, we settled on Trino and later on Presto DB. Ampool was acquired in 2021 by HPE, and since then I've been working at HPE Ezmeral as this group's chief architect and working on leading the unified analytics product as well as a few other products that we are offering. So um, today I will be talking mainly about maybe not a lot of people have heard about HPE Ezmeral. So we'll be talking a little bit about what we do inside of HPE. And then more about the specific product I will be talking about called Unified Analytics, which we recently launched. And then I will go deeper into how we embedded Presto DB inside of the Unified Analytics platform, what are the enhancements that we did, and what our future plans and open source contributions are that are planned, right? And I'll leave some time for Q&A. All right. So what are the challenges that we are addressing, right? The global enterprise analytics, every enterprise company is a global company. They have to think global, right? So as a result of that, they have their data as well as their infrastructure fragmented or distributed across multiple infrastructure platforms as well as multiple locations, etc. So in this setting, the distributed infrastructure, the data governance, access, management of data basically becomes really challenging, right? Um, Obviously, large enterprises basically adopt tools that are suitable for them in various silos. So how do we integrate these tools together? That basically becomes a major headache, right? And the third thing is when you have all these, enterprise grade analytics going on, the cost, especially for certain platforms, basically become high. And more than high, I think the problem is unpredictable, right? Depending on the use cases, your vendor lock-in, et cetera, right? So these are the three main challenges that we have seen in large enterprises, uh, actually enterprises of any sizes. And these are the things that HP Ezmeral is trying to solve. Okay, so two major options that people have available for today, right, is basically one is adopting the services that are offered on public clouds. The advantages of that is that hey, you can just sign up your credit card and spin up the analytics environment quickly. There are very low initial costs. There are free tiers, etc. And obviously, public clouds operate at scale, so these services are robust and scalable. But soon the problems start surfacing is that the costs become unpredictable. Some services that are offered by a public cloud provider are not available elsewhere, so you are essentially the proprietary locked in. These services may not be open and may not be extensible, right? I mean, so that is one end of things. People do try to adopt open source and try to do sort of do it yourself open source strategy, regardless of the infrastructure you are on, whether you are on premises or on the public cloud. The advantages there is that open source evolves really rapidly, right? And you get a lot of big a lot of choices in terms of which tools you use, and if you face certain problems with tools, maybe there are others in the world that have faced that challenge, and they have started with the open source as well. So you get continuous updates of these tools, right? And obviously, it's much lower in cost. But the disadvantages there are that it requires specialized skills to implement. You need to have large teams to keep track of what is happening in open source. You have to, implement it in production, and add the whole required open source security features, and then who do you turn to for support, right? So both those options, I think we can do better than that, and that is where HPE Ezmeral software plays a role, right? So HPE Ezmeral is focused on hybrid cloud by design, right? So which basically means including your on-premises infrastructure in colos as well as multiple public clouds. And our strong belief is that every organization, the end state of their infrastructure is going to be hybrid and multi-cloud, right? So we are designed for that. We designed our offerings for that, right? Two main offerings that we basically have is one is called the HPE Ezmeral Data Fabric, and the second one is HPE Ezmeral Unified Analytics. They are actually very closely integrated with each other, but those are two different products that we have. Okay. Specifically, what I am talking about today is our recently launched software offering called the Unified Analytics software, right? So our understanding of the data workloads in various customers is that people are looking for stitching together pipelines, end-to-end data pipelines, right from data collection, data engineering, data analytics, visualization, BI, reporting, all the way to data science, AI, ML kind of workloads, right? That to us forms the entire spectrum of data and analytics workloads, right? So what we have attempted to do here is we have taken for each of these use cases or each of these, I would say, stages in the data pipelines, we have taken the top one or two tools that address that use case really, really well, and that are open source, right? So for example, for data science, we have Kubeflow, MLFlow, feature registries such as Feast, distributed training platforms such as Ray. Data engineering, we focus on Apache Spark, Airflow for data pipelines, Livy for REST-based access to Apache Spark. And as you can see, the most relevant thing for today's talk is in the data analytics tool, we have an open source BI visualization tool called Apache Superset that is powered both by Presto DB on the backend as well as Apache Spark. And we know that every organization has different needs. They have various different open source as well as proprietary tools that they use. So we keep this platform extensible so that our customers as well as our consultants can then basically bring in, or services folks can be basically can bring in their own tools by integrating with this unified analytics platform. Okay, and I will be talking more about the role of that Presto DB plays inside of HPE Ezmeral Unified Analytics software. So some of the differentiators that we like to highlight in the unified analytics software is that it is hybrid by design, which basically means regardless of the choice of your cloud, public clouds or your private cloud or your on-premises bare metal infrastructure, because we are based on, or the platform is powered by Kubernetes, it is basically portable to run across any of these environments, and we are hybrid by design, right? It is open and extensible in that we provide the framework in order to bring your own tool sets. We basically provide you with SSO, so built-in security, observability, app level isolation, app as in these frameworks such as Spark and Presto. We call them app in the context of unified analytics. So app level isolation, access controls, etc., etc. Right. So all of this is available as a managed service, either a customer managed service or HPE Ezmeral itself can manage it for you. And we basically give you a predictable economics while using this platform. Okay, so that's all about the HPE Ezmeral Unified Analytics software product that I wanted to talk about, right? So for the last year or so, actually slightly more than that, we have been integrating Presto DB in the HPE Ezmeral Unified Analytics. The internal project code name is Easy Presto. So you'll basically see Easy stands for Ezmeral, and Presto you already know. So we also try to make it easy, and that's sort of the wordplay here. So Presto for us satisfies three different use cases, right? One is as an optimized MPP or distributed SQL execution engine over our Ezmeral Data Fabric. Now, if you haven't heard about Ezmeral Data Fabric, the long-term Hadoop folks here would know that HPE acquired MapR about 5 years ago. MapR had a proprietary distributed file system that was compatible with HDFS compatible or HDFS. And since then, they have actually added a lot of features to that, a lot of data genres or storage and access patterns, right from files to objects to streams to age-based compatible binary DB to a document database called JSON DB, and more recently Delta Lake tables and Iceberg, etc. Right. So in this context, right, Presto DB basically then becomes a single SQL engine, single distributed MPP SQL engine that can consume all these data genres and offers accelerated query processing on the Ezmeral Data Fabric. So that's the first role of PrestoDB. But as you know, PrestoDB has this nice connector-based architecture that allows you to connect to various data systems, data platform, and still have query execution run on top of that in a federated manner. So one part of that, which is basically connecting to these various data platforms, right? We have separated that out into a secure data connectivity framework powered by PrestoDB. So in technology terms, you can think of it as exposing virtual views, but in addition to that, we have the anonymization, column masking, bidirectional encryption and decryption, etc., added as a set of inbuilt features to those views that people can expose their views that they have built or derived data from their original data sources to other platforms. And the third use case that Presto satisfies for unified analytics is obviously a federated SQL engine, right? So we have created a data source registry, full-fledged SQL, sort of an intelligent SQL editor on the with the web interface. And what I will be talking more about today is that we have this is the technology that HPE acquired through Ampool, which is the embedded caching layer that we use inside of PrestoDB for performance reasons. Okay, so just to put that in the graphical form, the EasyPresto proxy as well as EasyPresto query engine, both are the PrestoDB powered, and our BI visualization toolkit such as Superset and even our data science notebooks and other ML workloads can fetch data through this EasyPresto by issuing Presto query engines. Presto can directly access, on-premises or cloud relational DBMS, other data warehouses, Ezmeral Data Fabric, even other Hadoop-based platforms. And then it can also talk directly. There is a Presto to Presto communication that is happening here, where EasyPresto proxy is also powered by PrestoDB, which offers virtual views currently. And the EasyPresto proxy can use connectors to all these data sources, but rather than exposing raw data coming out of the proxy, the Presto proxy can basically on demand or inline anonymize this data, do column masking and all sorts of different anonymization functions, right? In addition to that, we have Apache Ranger to have access control over the data that is exposed, as well as the catalog, which is the Hive Metastore, right? This is our internal catalog. Some of the enhancements that we have done for the PrestoDB in Unified Analytics is, first of all, as I said before, this is a completely Kubernetes-based deployment, including scale out, addition, removal of nodes, etc., etc. Second is we want our customers or our users to basically publish the data sets that they have created by simply filling up a form and making it accessible to the rest of the world or rest of the users internally that are using this EasyPresto with a single click of a button, right? So for that, the earlier limitations of PrestoDB, where when you add a new catalog, right? You have to either restart, when you add or delete a catalog, you have to restart Presto, although it's a very small, short time to bump Presto again, but it still causes a little bit of, disruption. So that functionality that we have added. Second one, we have improved a lot of connectors. A lot of great connectors are available from the open source community. We basically saw that there is a lack of better data type support, so we added those to MySQL, Postgres, SQL Server, etc. We added our own Snowflake and Teradata connector and CSV Parquet files with auto schema detection without having to register those files first as within another Metastore or something like that, right? The JavaScript web token, JOT-based authentication, we made some improvement and fixes there. And we have Ranger integrated authorization. Okay. We added the embedded caching layer, as I was talking about, and that's what I will be talking about next, right? So based on our earlier experience, right, from the file-based cache versus a caching layer that is specifically designed for analytic workloads, that is table aware or table fragment aware, gives us a lot better performance, lot better control over how things get accessed. So, and all the columnar, so even for CSV files, for example, right, when we cache the data rather than caching the raw files, which basically become a row oriented access, when we cache these files, we can store those in a columnar manner, right? So the way we have implemented this today is basically we modified the individual connectors with caching connectors, and I will be talking about more sort of how we plan to do this in future, right? So because of our we have to deliver this product in a very short time, we basically, the way we approach this is we took individual connectors and we basically made the each connector cache aware. Okay, so three types of caching, I would say, really. One is what we call as the user managed caching, where you basically, the user goes and looks at all the catalogs and says, hey, these are the tables that I am interested in, or maybe even the table fragments that I am interested in, and I want to cache those. So press a button, the data gets into the cache, and after that, whenever the user basically makes a query to the original tables, instead of going to the original table, the cache table is used. Okay. Obviously, in order to know which tables have been cached, etc., we have a central metadata store that is embedded within the cache itself. The second type of caching that we offer is system managed caching, which is basically the user doesn't know which tables they want cached, right? They are straightforward issuing queries. And at that query time, as it happens in Presto, right, with the projection and filter push down, we basically get a table fragment from the table scan node, right? At that time, the system transparently caches this data into our caching layer. So at the first time, there will be a little bit of overhead because you are going to the original data source. And while fetching that data, you are also caching the data. But later, once another query comes in and we determine that the query requires a table fragment from that data source, which is a subset of the data source data fragment that we have already cached, we will just use that cache, right? We think that result set caching is a subset of this materialized view caching, the way you look at it. And so I think there is a work in progress going on in order to provide result set caching as well, right? And the whole deal here is that even with explicit caching, that user should not have to rewrite their SQL query to fetch data from cache, right? The caching layer should be intelligent enough to know that what the user is requesting is already present in the cache. And so it basically substitutes those table fragments by the cache table fragments. Okay. All right. So moving on, what we want to do with this EZU Presto caching, right? And I will discuss about open or open source plans, etc., in the next slide, right? So we want to take this in memory, or I would call it a memory-centric caching layer, right? Memory-centric caching layer obviously is limited by the amount of memory that you have, right? Even if you pool all the memory that is available within your entire Presto cluster, or in our case, the Unified Analytics cluster, right? It's still going to be limited by the amount of total memory that you have, right? And your working set might not fit in that memory. So we added the feature to do tiering between memory as well as, and this is a distributed tiering mechanism based on uh, the memory pool that we construct out of these machines and the local file systems, right? What we are trying to do now is basically implement this tiering on top of the Ezmeral data fabric, which provides us with a high performance distributed file system. So both the distributed file system as well as the distributed memory pool basically forms a single unified caching layer, right? And in my earlier slide, I had referred to how we implemented this caching by modifying every connector that we supply or embed inside of the Presto DB. But I think we can look at a much better architecture where this is completely connector independent, because if we have to modify every connector to enable caching, then it's not going to be sustainable. It's not going to be scalable from our point of view, right? So the idea here, and this is the work in progress that we have right now, which is, can we have cache aware optimizers in the plan optimizer stage? So after the logical plan is generated, you can have rules that basically go over this logical plan and apply those rules on the logical plan to generate a physical plan. So at that level, can we basically bring in the cache aware optimizer rules, which will basically look at the logical plan and at that time consult the caching layer, and then substitute the table scan node in particular in case of reading by our own cache, or our own as in the caching layer's own table scan node, and that table scan node, in case of the first or the cache miss, will be replaced by the scan and write into the caching layer pipeline. But after that, once it finds the data into the cache, then it will basically substitute that table scan node by the caching table scan node, right? I think that is a much cleaner architecture, and I think that will apply to all caching systems, whether they are file-based caching systems, whether there are distributed file system-based caching system, or something like what we have done, which is a distributed in-memory caching system. Okay, so talking about our future plans and OSS contributions, as I said earlier, because we had to deliver this product in a hurry, and we had to get there as soon as possible, we have been tinkering with Presto DB and doing these modifications on our internal branch of Presto DB. And this is clearly not what we want to do going forward. We want to run the open source Presto DB without any HPE modifications on our end in the HPE Ezmeral Unified Analytics, right? So we are starting to work with the open source community. We are, sponsoring organization for Presto Foundation for almost a year now. So these are some of the open source contributions that you can expect from us, and we'll start discussion within the community very soon, right? So adding, modifying, deleting catalogs without disrupting or restarting Presto DB, right? But the most important one that we think that the community can help us with is making caching or cache as a first-class citizen, making SPI for a cache, which can be then used by different caching layers, right? That basically democratizes the cache for all of Presto DB customers, Presto DB users, right? That will make it a really, the best open source contribution, in my opinion, right? We also want to get community feedback for Presto and Presto parallel data transfer, right? We want to know whether anybody has been successful in doing that, what they had to do. The reason for this is that, as you saw in my previous architecture diagram, right, we had a Presto proxy and a Presto SQL engine. Presto proxy was doing, taking the virtual views and supplying those anonymization and column masking, etc., to whoever is asking for it, right? So if the whoever is asking for it is also a parallel agent, such as Presto, in that case, you should not have to go through the Presto coordinator, especially in the data path. The data path should be Presto worker to Presto worker in parallel, right? So we want to know from the community what they have done for such a use case, and would love to engage with the community for that. And with that, I can answer any questions that you may have. Okay, so we have a question in the Q&A. How do you manage Presto on Kubernetes? So we have uh, our own Kubernetes. We started with our own Kubernetes distribution, and we had our own operators, etc., for managing Presto DB earlier, right? But going forward, we want to make the unified analytics platform to be portable across multiple Kubernetes distributions, right? And so we have managed to deploy Presto and other open source tools such as Spark, Superset, etc., with Helm charts, right? So we have our own unified analytics orchestrator that talks to these individual open source packages or open source Kubernetes deployments or Kubernetes pods. But the open source pods themselves, they are just based on a CNCF Kubernetes. They don't make any assumptions about what different distribution of Kubernetes, etc., is there. I hope that answers your question. So I have, okay, another question is, any materialized views solely seen as user specific? Oh, sorry, are materialized views solely seen as user specified caching, or can they be managed by Presto platform table owners based on the queries they receive? Actually, so both, right? So materialized views that are explicitly specified by the user saying that, hey, I want to create these materialized views. And by the way, this is the time to live for that materialized views. And after that time to live, you have to go and refresh that view, right? So that is definitely possible. The second one that I was talking about is the system managed, right? Which is by a table owner, or even during the query, we see that, this particular data fragment, and this is not a very generic or very complex materialized view. This is basically, with whatever that connector offers, which is the predicate and projection pushdown, those table fragments, they are a special case of materialized view in our case, right? So those will be managed by the system. And in future, we can think about as a community as to, when do you know that now you need to refresh that materialized view? Do you get an alert from the source system saying that, hey, the underlying data has changed, so the materialized view is no longer valid, so you need to rebuild that view, right? So those are the things that we will be working with the community. Question. Okay. So how do you implement Presto catalog modification without restarting cluster? Okay, a good question. Modification is treated as a delete followed by an add, right? So if we allow the catalog to be deleted and even a new catalog to be added, right, without restarting the cluster, we allow Presto catalog modification without restarting cluster. That's the simple, 10,000-foot view. Obviously, for the queries that are going to be using that catalog, the queries that are in queue, they have to be stopped. Not everything else has to be stopped, but the Presto cluster doesn't have to be restarted. That's the goal here. I hope I'm answering that question to your satisfaction. Okay, so if there are no more questions, thanks everybody for attending the talk, and I will be sharing my slides through the organizers for the Presto event, and then you will see the recording as well. Thank you.